Hi viewers, my name is Rajkumar from RK Academy. Today we are going to see the topic complex number. It's from higher secondary second year. Already seen the examples of 2.3. Today we are going to see the exercise problem, exercise 2.3. Yes. The very first problem. Three events are given, Z1, Z2, Z3. Three complex numbers are given. Now we are checking out the associative. It's from addition. Now we are checking the addition property of the associative. Okay, now listen. What will happen? Very first, you take the LHS and expand, and you take the RHS and expand. We are going to check whether both are equal or not. Yes, Z1 plus Z2. Now we are taking first is to take the bracket. Z1 plus Z2. What will happen? Z1 1 minus 3i plus Z2. What is Z2? It's a single value. It's completely imaginary. You can write 0 minus 4i. 0 minus 4i. Now what about the real part? 1 minus 7i. Now Z1 plus Z2 is over. What about Z1 plus Z2 plus Z3? Okay. Now you take the Z1 plus Z2. It's what? Z3. What about Z3? It's 5 plus 0i. Because there is no imaginary values. Okay. 1 plus 5 is 6. Minus 7 plus 0i, minus 7i. Now we completed the LHS. Now what about the RHS? In RHS, listen. Z1. Now we are taking the bracket value. What about that? Z2 plus Z3. What about Z2? Z2 is minus 4i plus, 0 minus 4i. Okay, we can write like this. 0 minus 4i plus, what about Z3? 5 plus 0i. 5 plus 0i. So first real part, it's 5. Imaginary part, minus 4i. Yes. So what about the next one? Z1 plus Z2 plus Z3. So what about Z1? 1 minus 3i plus, what about Z2 plus Z3? You know that 5 minus 4i. What will happen? 6 minus 7i. From 1 and 2, both are equal. So the associative is proved by addition. In that same manner, we can prove that the multiplication of associative. Just you try that. Okay. Now listen, the second one. What about the second problem? Now you see the second problem. It's distributive. What is the distributive? Now we are taking three values, Z1, Z2, Z3. Z1 into Z2 plus Z3 is equal to, what about that? Z1, Z2 plus Z1, Z3. Yes. First you take the Z2 plus Z3. Z2 plus Z3. Z2 plus Z3. What is Z2? 0 minus 7i plus Z3. 5 plus 4i. 5 plus 4i. What will happen? The real part is 5. Here it's 0. So minus 3i. Minus 3i. Again what we are going to do? Multiply by Z1. Z1 into Z2 plus Z3. What will happen? What is Z1? Z1 is 3 into, what about Z2 plus Z3? 5 minus 3i. So 15 minus 9i. Yes. You take this one as first. It's LHS. What about the RHS? Z1 into Z2. Z1 into Z2. What is Z1? Z1 is 3. Z1 is 3. Into Z2 minus 7i. What will happen? Minus 21i. as usual product. Again, Z1 and Z3. What is Z1? 3 into Z3. 5 plus 4i. So now it's 15 plus 12i. Now what we are going to do? Sum of these two. I mean Z1 plus Z2 plus Z1 into Z2. Z1 into Z3. So minus 12i. Sorry. Minus 21i plus 15 plus 12i. What will happen? Okay. Now listen, what about the real part? Real part is 15 minus 21 plus 12. I mean minus 9i. It's the second one. Now the distributive of this one is true. Okay. Okay, we can just try this one. Now the third one. What about the third one? Listen. There are given three complex number. We are going to find additive inverse of additive and multiplication inverse of Z1, Z2, Z3. Now we are going to find out the additive inverse of these three and multiplication inverse of this one. Okay. Z1 is given. What about additive inverse? Addition. We are adding this one by any number, it's equal to the same value. What about the additive identity? Identity is 0. We need the solution 0. We are adding Z1 plus dash when you will get the 0. When you will get 0. That is identity. In the last class, previous class, we have already seen about the inverse and identity of additive and the multiplication. Now what we are going to put here? Additive identity, Z1. So 2 plus the additive inverse. Additive inverse. So Z1 is equal to 2 plus 5y. The additive inverse of Z1 is equal to minus 2 minus 5y. Okay. Z2. What is Z2? It's given minus 3 minus 4i. The additive inverse 3 plus 4i. 3 plus 4i. Like that same manner we are writing this one. Okay. Multiplication. Multiplication inverse. How to find? We know the formula. X plus iy is a complex number. What about the inverse of x plus iy is equal to x by x square plus y square minus I into y by x square plus y square. Now listen. Now we are taking some complex number Z1. Z1 is equal to, what is that? 2 plus 5i. Now I am writing the additive inverse. How to write? Sorry, multiplication inverse. Multiplication inverse. Z1 inverse. So it's the inverse. It is Z equal to x plus iy. This one is Z inverse. Okay, how to write? Real part by sum of the real and imaginary part square minus I into imaginary part by sum of real and imaginary part square. Okay, 2 by 4 plus 25 is 29 minus I into 5 by 29. So it's the inverse of this complex number. We may use this formula for all inverse of the complex number. Same manner we can use this one. Okay. Now just you try the Z2 and Z3. It's very easiest one. Okay. Now we completed the 2.3. Now we are going to enter the 2.4 in next class. Okay, thank you.